Hello everyone, welcome back. In this video, I will be covering indefinite integrals and the net change theorem, which is chapter 5, section 4. So in chapter 5, so far we have seen how to find the area under a graph of a function. So when we say derivatives, and it is about the rate of change, velocity and instant velocity. When we say integrals, antiderivatives, it means area under a graph of a function. Because area under a graph of a function is not an easy process. We had finding the area using approximate methods, which are by left endpoint intervals, right endpoint intervals method, and also midpoint rule, which we saw in section 1. In section 2, we saw how to approximate the integral by Riemann sum method, how to find the area under a graph of function by summation method, which is Riemann sum method. Then in the third, we have seen fundamental theorem of calculus, part 1 and part 2. In this section, we are going to see indefinite integrals and the net change theorem. So here, both parts of fundamental theorem establish connections between antiderivatives and definite integrals. Because of the relation given by the fundamental theorem between antiderivatives and integrals, the notation integral f of x dx is traditionally used for an antiderivative of f and is called an indefinite integral. Thus, integral fx dx equal to uppercase f of x, which means if you take the derivative of the answer, so antiderivative is f of x. If you take the derivative of the antiderivative, you get the original function back. So integral lowercase f of x dx is uppercase f of x, which is that the answer, which is the derivative of the answer, which is uppercase f prime x equal to lowercase f of x. For example, we can write integral x squared dx as the antiderivative, which is x cubed over 3 plus c, because if you take the derivative of the answer, if you take the derivative of x cubed over 3 plus c, let's do that on the side. Actually, we are doing the derivative of the antiderivative. So we have to take one by one derivative. We have to do the derivative one term at a time. So which is 1/3, which is a constant. And then you have to take the derivative of x cubed, which is nothing but 3x squared. And then derivative of a constant that is equal to 0, so which is x squared. So the derivative of the answer, which is uppercase f of x, which is also known as f prime x, equal to x squared, the integrand, which we call as lowercase f. And it is the integrand. So we can regard an indefinite integral as representing an entire family of functions, one antiderivative for each value of the constant c. So as we vary c, we get the same family of functions. They are all shifted up or down. Okay, so they're the same family of functions, x cubed over 3. If c was positive, it is shifted upward vertically. If c was negative, it will be shifted downward. So they are the same family of functions. You should distinguish carefully between definite and indefinite integral. A definite integral will have a lower limit and an upper limit as shown here. Integral a to b fx dx is a number, whereas an indefinite integral, integral f of x dx, where there is no lower limit or upper limit, is a function or family of functions. So we can use some of the antiderivative formulas that we have already seen. Integral c f of x dx is c times integral f of x. integral k f of x equal to k dx equal to kx plus c. K can be taken out. Integral of 1, the antiderivative of 1 will be just x. So kx plus c. Integral x to the n dx is x to the n plus 1 over n plus 1 plus c, where n is not equal to -1. That means what happens when x equal to n equal to -1? So when n equal to -1, x to the n would become x to the -1. So when we do integral x to the n, it becomes integral 1 over x. So integral 1 over x dx is ln of absolute x plus c. The reason is if you do the derivative of the right-hand side, and you are going to get the integrand. Integral e to the x is e to the x plus c. Integral sine x is negative cosine x plus c. Integral secant square x is tan x plus c. Integral secant x tan x is secant x plus c. Integral 1 over x square plus 1 dx is tan inverse x plus c. Inverse tan x plus c. Integral sine hyperbolic x dx is cosine hyperbolic x plus c. Integral a to the x, note, here it is e to the x, here it is a to the x. It is a to the x divided by ln a plus c. Integral of cosine x is sine x plus c. Integral of cosecant square x is negative cotangent x plus c. So you have these bunch of formulas here. So keep in mind, if any these things should be memorized, it's a good thing to memorize because we will be coming across these formulas many times in our problems, and also in your next level calculus class. So it's worthwhile memorizing them. The thing is that whenever you get confused, after you write the answer, if you get confused, then make sure that you differentiate the right-hand side and see whether you get the left-hand side integrand. That's one way to check whether you're doing the antiderivative process or integral process correctly or not. So main thing, you need to memorize this set of formulas. We will be adding some more to this. So it is better to memorize them as and when we do the section. What is net change theorem? Which I mentioned that when we did the earlier theorem, section, fundamental theorem of calculus part 1 and part 2. Now, what is net change theorem? The integral of a rate of change is the net change. So integral a to b f prime x dx is uppercase f at the upper limit, uppercase f minus uppercase f at the lower limit. Okay. So let's revisit this. What do we mean by integral a to b f prime x dx, uppercase? So what is the relation between uppercase f and the lowercase f? Lowercase f is the derivative of uppercase f because uppercase f is the antiderivative, right? Uppercase f is the antiderivative of lowercase f. So the derivative of the antiderivative will be the lowercase f. So here in this one, if you do a to b, so instead of writing f prime x uppercase, instead of writing, if you write the way it is f of x, if you replace that by fx dx, so integral a to b fx dx can be written as integral, so we will write like this, integral a to b fx dx can be written as integral a to b f prime x dx. So now you have derivative and antiderivative. So by fundamental theorem of calculus, they kind of get cancelled out, and you get the function f of x back, which is evaluated at the upper limit and the lower limit, f of b minus f of a. This was precisely fundamental theorem of calculus part 2. If v of t is the velocity or volume, is a volume of water in a reservoir at time t, then its derivative v prime t is the rate at which water flows into the reservoir at time t. V prime t is the rate, being the derivative. So if we do integral t1 to t2 v prime t dt, we do the integral of the derivative, then you get the original function v at the upper limit minus v at the lower limit, which would be the net change of the volume. If c of x is the cost of a commodity, cost of producing X units, of a commodity, then the marginal cost, which is the derivative, then the marginal cost is the derivative C prime X. So integral x1 to x2, that is x1 of units to x2 of units, C prime X dx, which is the integral of the marginal cost, integral of the derivative of the cost function, which is cost at the upper limit minus cost at the lower limit. It is the rate of change. It is actually the change or increase in cost in producing X2 units versus producing X1 units, the cost difference is the increase in cost when the production is increased from X1 to X2 units. If an object moves along a straight line with a position vector S of S, then its derivative, then its velocity is the derivative, is V of t, which is S prime t. So integral t1 to t2 vt dt. So note here, what is V of t? It is the derivative of the position. Now you have integral and the derivative. So they kind of get cancelled out. So you get the function back where the function is evaluated at the upper limit minus a function evaluated at the lower limit. This is change in position or the displacement. It is a net change of position or the displacement of the particle. During the time period from T1 to T2. So fundamental theorem of calculus has a great application by way of net chain theorem. In fact, it is an application which is used in every field of science. Let's take up some additional problems to practice this concept. So there are some videos which are already made. You will see them in the section videos. For example, practice test number 16, practice test number 22, number 27, 39, 45, then 69, 71. All these are done in the section videos. For this video, we will do a couple of problems. So watch the videos for the following problems. $69, $71. So let's try number 13 here. So we'll try integral of, this is number 13. There's also a homework question. U plus 4 times 2u plus 1 du. What kind of integral is it? Is it definite or integral? Yeah, indefinite. As we don't have any lower limit or upper limit here, it is definitely an indefinite integral. The indefinite integral will end up with a function plus an arbitrary constant. So to do this, we will FOIL, so it is 2u square plus u, then 8u square plus 4. Let's simplify, combine the like terms. So 10u square uh, 2u square plus u plus 8u only, just 8u. So it is 2u square. Combine the like terms, that will be a 9u plus 4 du. Now you have to integrate term-wise, 2u square du plus integral 9u du plus integral 4 du. So it is 2 u cube over 3. 2 can be taken out. Integral of u square is u cube over 3. By what rule? By the power rule that we just stated. Integral of x to the n is x to the n plus 1 over n plus 1. So integral of u square is u to the exponent plus 1 over exponent plus 1. 9 is a constant which can be taken out, and which this can be written as integral u to the power 1. So it is u square over 2, then 4 integral 1, that will be just the variable u. Remember to add the constant. So it is 2u cube over 3 plus 9u square over 2 plus 4u plus c. That is the value of the integral. Integral u plus 4 times 2u plus 1 du. So all we have done in this problem is to expand by FOIL and then integrate term-wise. Let's try another problem which involves definite integral, where you see a lower limit and an upper limit. We'll try one of those. And then many other problems are done in the video. Please check them out. So integral -2 to 0, half t to the power 4 plus quarter 1/4 t cube minus t dt. So let's try that problem. This being a definite integral. It is definite integral because of the lower limit and upper limit being present. So what do we do? By fundamental theorem of calculus. So if you have integral f of x dx, a to b, then what do? You take the antiderivative and plug in the upper limit and minus antiderivative at the lower limit. So let's do the antiderivative first. So we will call the given integral as I. I is just another representation for the given integral. So I'm going to integrate each one of them, right? So half t to the power 4. So on integration, it becomes t to the power 5 over 5 plus 1/4 t to the power 4 over 4 minus t square over 2. This needs to be evaluated between -2 and 0. So if I simplify this, it's 1/10 t to the power 5, 1 over 16 t to the power 4 minus t square over 2 between the limits -2 and 0. At the upper limit, all the terms involve t, so it's going to be 0. Now at the lower limit, substitute the lower limit, 1/10 -2 to the power 5. Remember, you have a minus sign in front. Plus 1 over 16 -2 to the power 4 minus 1/2 -2 square. So this will become negative. Keep the negative for the time being like that outside. 1/10. This will be a -32. 2 to the power 5 is 32 with the negative sign. This is an odd exponent, so it will remain negative. Then plus 1 over 16, -2 to the even power, so it will become positive. So that will be 16 as well. Then minus 1/2, -2 uneven power, that will be positive. -2 square, that will be a 4. So if I simplify this, I get negative, I can further simplify this, negative 16 over 5 plus 1 minus 2. That's negative 16 over 5 minus 1. So you have negative outside, you have negative, every term has a negative inside. So that becomes positive. So which you reduce, if you simplify, it will become 21 over 5. So note that definite integral have a finite answer to be a number. Definite integral will end up with a number when evaluated will have a number as its answer. But indefinite integral will be a function or family of functions. By changing the constant value C. Hope this video helps, and make sure to watch the other practice exam videos in the section video, which will be called, the section video will be called Calculus 1, section 5.4. So you have to look for these videos in that section. And also you can find them in the practice exam videos. So watch my next video on section 5.5.